multiplication with matrices. If I just asked you this question, we're going to start out with something pretty basic. In order for matrices to be equal, all of their components have to be the same. So every row and every column is identical. So with me never having done an example like this, if I asked you what all of your variables would have to equal to make these two matrices equal, what would you guess? What would you think x would have to be? 2. What do you think y would have to be? What do you think p would need to be? And q would have to be 0. And that's it. If matrices are equal, all their corresponding entries have to be the same. So row 1, column 1 has to be the same in both. Okay, so something like this, you could easily tell me what your variables had to be, right? Just the corresponding numbers have to match up. Let's say I asked you to find the sum and difference of these matrices. In order to add or subtract matrices, they have to be the same size. So if I want to do A plus B, all I'm asking you to do, I'm going to show my work just because this is the first example we've done. You don't necessarily have to write this out. I am asking you to add matrix A to matrix B. So without ever having an example of this, what do you think you would do? Yeah, you're just going to add up the corresponding entries. So you would do 2 plus negative 3. Negative 1. Moving on row 1. So 4 plus 4, 8. 8 plus 0. Negative 3 plus 1. Okay, going to row 2. 0 plus 6. 1 plus 8. 2 plus 2. And 3 plus 0. It's not 0, it is 3. Okay, so we could add matrices. If I asked you to do A minus B, what do you think you're going to do? Just subtract the corresponding numbers. Some people would rather distribute the negative, and that's fine. So you can either run a negative through everything in the second matrix and then add them, or if you're comfortable with subtraction, just think about subtracting as we go along. So 2 minus negative 3. 2 plus 3 is 5. 4 minus 4. 8 minus 0. Negative 3 minus 1. 0 minus 6. 1 minus 8. 2 minus 2. And 3 minus 0. Have I lied to you yet? Any questions so far? Let's look at this example. I'll give you a second to jot these down. We're going to do, so if you had to guess, part A. What do you think 4A means? Yep, take every number in matrix A times a 4. So we get 12, 4, 20 for row 1. Row 2 would be negative 8, 0, 24. Okay, part B. Each number in matrix C times 1/3. So 9 times 1/3 is 3. 0 times 1/3 is 0. Negative 3 times 1/3 is negative 1. 6 times 1/3 is 2. Sometimes these questions show up on the ACT too. And a lot of people just panic because they haven't seen the matrix before, but they're very simple. You can usually find them pretty easily. C wants 3A minus 2B. So I'm asking for something a little more complicated, but we can still do that. You're going to do 3 times the number in A. So if I'm just talking about the first one, it'd be 3 times 3 minus 2 times the number in B, minus 2 times 4. So we would get 1. Okay, moving down row 1. 3A, so that would be 3 times 1, minus 2B, so that's 2 times 1. So 3 minus 2 gives us a 1. Okay. Row 1, column 3, 3A. So 3 times 5 minus 2 times 0. So we get 15. Okay. 3 times negative 2 is negative 6 minus 2 times 8. So negative 6 minus 16. 3 times 0 minus 2 times 1, so 0 minus 2, negative 2. 3 times 6 minus 2 times negative 3, so 18 plus 6. Are we okay with all those? Do we need extra examples of any of that stuff? The next thing I want to talk about is the multiplication. When you multiply matrices, you do not just multiply corresponding numbers. So we are going to start out with just multiplying a row times a column. When you take a row times a column, you will actually get a single answer. The rule is you will multiply the corresponding numbers together and then add those pieces. So I will take 3 times 3, which is 9, negative 5 times 4, and 2 times negative 5, and then you add all those together. So if I take a row times a column, I get a single answer, in this case, negative 21.
Can you explain what you did again?
So I took the first number in each one, multiplied them. Second number in each one, multiplied. Third, multiplied. Then you add those together. To add or subtract two matrices, they have to have the same size. To multiply, the rule is, since we are going to end up multiplying rows and columns together, the number of columns in the first has to equal the number of rows in the second. So you should jot this down. In multiply matrices, order matters. So the rows in the second one has to match the columns in the first. Easy way to think about this. I gave you a matrix. What's the size of this first matrix? So 2 by 2. What's the size of the second matrix? 2 by 3. If you write your sizes, if these numbers are the same, you can multiply. The size of your final matrix will be these. So in other words, in this particular problem, I can multiply them. My final matrix will be a 2 by 3 matrix. So the inside numbers have to be the same. The outside numbers will tell you the size of your answer. Let's actually multiply one of these things. Order is very important when we do this multiplication, so we have to watch that. What is the size of the first matrix? It's a 2 by 3. What's the size of the second one? 3 by 4. Since my 3's match, that means I can multiply it. What size will my final answer be? 2 by 4. So I should have 2 rows and 4 columns. So those are the numbers we have to find. When you multiply, you will multiply rows by columns. So to get this entry, this is in row 1, column 1. So I will take row 1 times column 1. Okay, so remember when we multiply those, we multiply the corresponding numbers and add them together. So 2 times 2 is 4, plus 4 times 4 is 16, plus -1 times -3 is 3. So I get a 23 for that number. Have I lost somebody? So moving on. My next number is in row 1, column 2. So you have to take row 1 times column 2. So when I multiply those, 2 times 5 is 10, 4 times 8 is 32, negative 1 times 1 is negative 1. Add those together, you get 41. Next, I want the number. This is row 1, column 3. So you take row 1 times column 3. So 2 times 1 is 2. 4 times 0 is 0. Negative 1 times negative 2 is 2. Add those together. 2 plus 0 plus 2 is 4. Last, I want row 1, column 4, so you take row 1 times column 4. So 2 times 4 is 8. 4 times 6 is 24. Negative 1 times negative 1 is 1. And that gives us 33. Everybody follow that? The next number I need is row 2, column 1. So that means I have to take row 2 times column 1. 5 times 2 is 10. 8 times 4 is 32. 0 times negative 3 is 0. And I get a 42. Row 2, column 2. So row 2 times column 2. 5 times 5 is 25. 8 times 8 is 64. 0 times 1 is 0. And we get 89. Row 2, column 3. Row 2 times column 3. 5 times 1 is 5. 8 times 0 is 0. 0 times negative 2 is 0. We get a 5. Last one, row 2, column 4. So row 2 times column 4 gives me 20 plus 48 plus 0, and we get 6. Any questions about the multiplication? Oh, absolutely. As long as you're putting your numbers in the right spot. Other questions? So let's look at this one. Okay. The first one, what size is it? 2 by 2. The second one is, so the 2's match, so we can multiply them. The size of our answer will be 2 by 4, so 2 rows, 4 columns. So we have to get 8 total numbers here. Working through here, row 1, column 1, 2 times 2 is 4, -2 times 3 is -6, so I get a -2. Row 1, column 2, so row 1 times column 2, 2 times 1 is 2, -2 times -1 is 2, so we get a 4. Row 1, column 3, 2 times 2 is, or 2 times 4 is 8, -2 times 3 is -6, so we get a 2. Row 1, column 4, 2 times 6 is 12, -2 times 2 is -4, so we get 8. Moving on to row 2. Row 2, column 1, 1 times 2 is 2, 0 times 3 is 0, so we get a 2. Row 2, column 2, so 1 times 1 is 1, plus 0 is 1. Row 2, column 3, 1 times 4 is 4, plus 0 is 4. Row 2, column 4, 6 times 1 is 6, plus 0 is 6. Is that okay? Why don't you guys try this one? Size of the first matrix is? Second one? So we can multiply them. How big will the final answer be? Okay. Row 1, column 1. So you have 1, -2, and 6. So you get 5. Row 1, column 2. You get 2, 0, and 12, so 14. Row 2, column 1, you get 0, 1, and 8, so that's a 9. And row 2, column 2, you get 0, 0, and 16, so that's a 16. We get that one? All right. Last one. Actually, no, I don't want to do this one. Can I change it? Okay. You guys don't mind? So agreeable. Size of the first matrix? 3 by 3. Size of the second matrix? So what does this mean? We can't do it, no solution. Okay, so make sure you're watching that. If I flipped them and wrote them in the other order, would it work? Yes. So multiplication order really makes a huge difference on these matrices. All right, is that okay with everybody? There's a handout posted on Classroom. You've got time to work on that.